Hello, I'm Jean-Louis Leroy from Bloomberg. Welcome to my talk on open methods and my library yomm2. Since we have only half an hour, I'm going to take questions, but at the end, please. So let's start with a typical case study. You want to create a representation of an arithmetic expression and evaluate it. You want to create an AST and manipulate it. So typically, you can write an abstract class node that has a pure virtual function value that returns the value of the node, and you derive several concrete classes from the node class and override the value function. Here's number, which simply returns the value that is stored in a number. And you have plus, times, and so on and so forth. This is a very, very common design, very reasonable. And then you can now build trees and evaluate them by calling a value function on the expression. And it works nicely. Now, let's suppose that you also want to render the tree, for example, in a reverse Polish notation, like in a fourth language or HP calculators, okay? So we want to write something, call a function or whatnot, that is going to render the tree as a string, and then we'll print the value. So how can you do that? Well, there are several options. The most natural in C++ is to simply plant a new virtual function in the node abstract class. Let's call it 2rpn, and override it in the subclasses. So that will work well in a small, self-contained application. But if you start reusing your hierarchy in several applications, you're going to run into a problem. And someone has described it as this. The problem with OOP is that you wanted a banana, but you also got the gorilla and the entire jungle that comes with it. And indeed, imagine that you now use this hierarchy in an application that does not render strings as reverse Polish notation, maybe as infix notation. The 2rpn function is still going to get pulled in because that's the way virtual functions are implemented, tables of pointers to functions. And even worse, since 2rpn returns a string, you're going to get the string class as well. But maybe your application doesn't need to render the tree. Maybe it doesn't even need the string class. So this is quite a big problem with OOP. Then there are alternatives. For example, you could use a type switch. You use dynamic cast to try to cast the node base class into all the possible concrete subtypes. And you do what's right depending on the result. The problem with this is that it's not very maintainable. Each time you add a new subtype to node, you have to update the type switch. And it really hinders the possibilities of reusing the hierarchy across different applications, because applications may add their own node subtypes. Then we can use patterns like visitor. So if, as a library designer, you design your class so that it can be, your hierarchy so that it can be, used in many contexts, you may provide a visitor. I'm not going to go into the details. You all know what that is. There are many ways of implementing visitors. Does it recur by itself or not? So after quite a lot of work, now the user of your library can subclass the visitor and implement rendering as an RPN string. So now we can add behavior. A user of your classes can add behavior to the hierarchy, but we have the same problem as with the type switch. What if someone adds new subclasses? So once again, this is not really extensible. And it's very ugly, in my opinion. And then there's yet another solution. You could use a function table. You create a map indexed by the type index of the node. So you use type ID to retrieve the type info, convert it to a type index, and then you use that as a key into a map whose values are functions to call, depending on the type. And you can even initialize that map using static constructors. And actually, this is not that bad because this is extensible, right? Your application and my application can add new node subtypes and new functions. So it's not that bad, except that it's very verbose. You have to do the casts yourself, and it doesn't know about inheritance, right? You cannot give a function that will work for any node type, or you have to cover all the possibilities. Okay, so let's take a little survey. Who likes the first option, plant a new virtual function? Raise your hand. Oh gosh, nobody likes it. Okay, who likes the second function? Oh, you do. Who likes the second? No. Who likes the second option, type switch? One who likes the type switch. Who likes the visitor? Oh, that's a few. And who likes the function table? Ah, good. This is encouraging. Because this is extensible, right? We have been actually grappling with something called the expression problem. So the expression problem is this. You have a family of types, and you have behaviors. In C++, typically, we express that as a class hierarchy with virtual functions and virtual function overrides. And the expression problem is that you want to add new types to existing behaviors. And in C++, it's easy. You simply derive new classes and override virtual functions. But it gets much more difficult when you want to add new behavior to existing types. Functional languages are better at that. But usually you want both. And actually, I gave you the example of that little, toy expression evaluator. But if you start, writing bigger programs, especially with multi-layer architectures, where you have a domain layer, and above it a presentation layer, and below it a persistence layer, well, you want to vary the behavior, the presentation, depending on the dynamic type of the objects in the domain model. And that's how you sometimes end up putting virtual functions in the domain class that returns, I don't know, a widget or a dialog. I've done that at one point. It's ugly. So actually, the expression problem you offer, it's quite a common problem. Now, there is a great solution to the expression problem, and that is called open methods. Open methods, we're going to look at them, but it's just virtual functions declared and defined outside of a hierarchy. yomm2 is a library that implements support for open methods. Maybe someday C++ will have them as a native feature. It has been proposed in the past, but in the meantime, let's look at what it's like using my library. First, there's a bit of boring boilerplate to do, so you have to include the library's header, which comes in two versions. The queued header gives you lowercase names for a series of macros. This is what I'm using here. And you have to tell yomm2 about your classes and the inheritance tree. And yes, multiple and virtual inheritance are supported. And before calling any open method, you have to call a function called update methods. Right. Now, let's solve that RPN rendering problem using open methods. So we have that declare method, and what follows, it looks very much like a normal function declaration. This macros creates an ordinary inline function that is going to, well, to do the right thing. Below I have two other macro calls, which are define method, and define method provide a specialization of a 2RPN method, one for number, one for plus. If we look again at declare method, we see that, what does it say? It says that we declare a function called toRPN that returns a string and that takes a node. But I have decorated node with virtual bracket. This says that when selecting one of the specializations, we take into account the type, the runtime type of the node. So this is just like virtual functions, except that it doesn't belong to a class. It's not a member function. It's a free function, okay? And you call it like an ordinary function. Okay, this is the key slide. This is the feature. We can add polymorphic behavior from the outside. So this is virtual functions from inside a class hierarchy. This is virtual functions outside a class hierarchy, right? This is closed. Open methods are open. You can add as many of them. Your application can add them. It's the application's business to decide how to render the tree, how to print the matrix, how to let the user edit some domain object. With this, you get the entire jungle. With open methods, you just get the banana. Okay? That's all there is to it. Well, almost. So, you know, that value function, it seemed natural, but let's think about it again. The value function, the value virtual function, it's just another way of rendering the tree as a number. This screams interpreter. You know, if it was not a toy, if it was a real AST library, and where I tried to use it in a compiler, I would have no need for the value function. So once again, value, in fact, it's just like toRPN. It's a cross-cutting concern. The tree classes should just do their tree business. And value is a processing of the tree, just like toRPN. So I argue that, in fact, even value should be an open method outside of the class hierarchy. At this point, I'm often asked, does it support multiple dispatch? Yes. So what is multiple dispatch? Sometimes it's convenient to select the right thing to do, the right behavior, depending on more than one virtual argument. A typical example is matrix addition. If you add two matrices in general, you just add all the elements. But if you know that both matrices are diagonal matrices, and if you know that only at runtime, then you want to pick a better algorithm. You just want to add the diagonals and return a new diagonal matrix, which will store only the diagonal. This is an example of multiple dispatch. It's something that you can implement using double dispatch. It's a well-known technique, yeah. Well, sometimes it's convenient to have more than two virtual arguments. For example, in text-oriented adventure games, you have situations where a character fights a creature using a device. And if the character is a human and the device is an axe or a magic wand, he cannot use it, but if he's a warrior and he's trying to use an axe, he can use it because he's agile enough to wield, but if he tries to use it against a dragon, it ends badly, right? This is an example of a multi-method that uses 3 virtual parameters. So that happens too. Well, good luck implementing that with triple dispatch. And the syntax using yomm2 is very simple. You simply use the virtual decorator on more than one argument. So the only requirement being that, of course, the classes on which you use the virtual specifier have to be polymorphic types. They need to have at least one virtual function, probably the destructor. And how does it select in presence of multiple virtual arguments? How is the function to be called selected? Well, I don't need to tell you. You already know the rules. It's exactly the same rules as overload function resolution, except that it happens at runtime. It's also exactly the same rules as partial template specialization. So you know the rules. I'm going to skip over next. Next is a way of calling the function in a base class. It's the equivalent of calling the function that has been overridden. I prefer to save some time. Okay, performance. Open methods are, at least in this implementation, almost as fast as virtual functions supported by the compiler. I have a benchmark here, benchmarks. You take them with a grain of salt, but according to my measures, in a case which is not so favorable to open methods, calling an open method with one virtual argument, which is the exact equivalent to calling a virtual function, is within 16–20% slower than a virtual function. So it is very fast inside, and tomorrow I will give a talk about what goes on inside. It uses dispatch tables and indexes, integer indexes, just like virtual functions. And here is the code which is generated when you call an open method with one virtual argument. Now, I split the code in two paragraphs. If you look closely, the instructions in the first paragraph are independent, meaning that they can execute in parallel. So if the body of your function does any bit of work, you won't be able to see it. So don't worry about the performance. They're almost as fast, and in practice, as fast as normal virtual functions. Okay, now let's do a bit of philosophy. Is this still object-oriented programming? The history of OOP is quite interesting. It started with Simula, which was the major source of inspiration for C++. And the first language that really popularized OOP was Smalltalk. And those languages come with a nice metaphor. Objects send messages to one another, and each object reacts to the message according to its nature. You kick a dog, it barks. You kick a pit bull, it barks and it bites back. Around 1985, another path was explored by the Lisp community, and they created the Common Lisp object system. CLOS, or CLOS, has open methods, has open multi-methods. And in fact, when you think about it, an open method or an open multi-method, it's much more like a rule. It's not about sending messages and seeing the world in terms of objects. It's rather selecting the appropriate algorithm depending on the type of one or several arguments. Once again, here in this approach, algorithms, function take back the front stage. That is what Stepanov has been saying about STL, right? Algorithms matter. And then, if needed, you split the world into objects, but sometimes it's simply not the right approach. So, in my opinion, this is not really OOP. So, recently, object-oriented programming, well, in the last 10 years, fell out of grace. It's really reviled now. But I think that we shouldn't throw the polymorphic baby away with the OOP bathwater. I know that template metaprogramming and so on is cool, but you're not going to write Excel at compile time. On a side note, back to virtual member functions. Have you ever realized that, have you ever noticed that, if you want polymorphism, you are forced to use, to make your function a member. There was that little algorithm by Scott Myers. He said, make your functions free functions, and then he gave you an algorithm to decide whether a function should be a member function. And the very first rule was bizarre. Basically, it said, if it needs to be virtual, make it a member function, right? It's not good advice. It's simply admitting that we have no other choice. And if you want to be a virtual function, you have to be a member, and snap, you get access to the object's private parts, when most of the time you don't need it. That's what's so strange about OOP, the C++ Simula Java way, is that polymorphism and encapsulation, they're like Siamese twins for no good reason. If you want one, you get the other. Well, not anymore. Now you have that option, open methods. It has been proposed for inclusion in the language as far back as 2006. Björn Slåstrup and two of his students wrote several papers about it. So I engage you to read them. I hope that we get them in the language someday and we can retire yomm2. But in the meantime, you have this option, and as you've seen, so let's take a survey again. So what do you think of solving that RPN rendering using open methods? Who likes it? Oh, splendid. Okay, so tomorrow at 12:30, I'll give a 1-hour presentation describing the techniques that I use inside yomm2. Some of them are interesting. You can use them to do other things, of the same kind, extending runtime type information. So you are welcome to come tomorrow. And now we have 8 minutes for questions and comments. Yes?
Is this ALP, like I remember in a previous life, in the previous stack, middle 2000s, aspect-oriented programming came out and was, kind of, it seems like that. You mentioned cross-cutting concerns. That triggered memories 15 years ago.
Okay, so the question is it similar to aspect-oriented programming?
Yes.
Okay, so I would say no. Aspect-oriented programming is a way of addressing the expression problem. Earlier today, we had a great talk about dynamics, which seems to me more similar to aspect-oriented programming than open methods. They're just tools. I'd say it's good to have many tools in your toolbox. Yes?
You mentioned it's like rules, and it made me think of like matchers and Haskell, stuff like that. Is that what this is more similar to, like you writing a matcher?
So the question is this similar to matchers, to maybe you have in mind open pattern matching?
Yes.
Okay, so Yuri Solodky wrote a great dissertation about several approaches to the expression problem, and one of them is open pattern matching. Well, he also considers just pattern matching. In my opinion, open is important. If you're going to write libraries, that was the big promise of OOP, right? In the 90s, it was going to be wonderful. Modularity, they called it software ICs. You were going to take classes, put them together, and it would just work. And it failed, right? So open pattern matching is one of the solutions. Yuri Solodky gives benchmarks about it. He says that open, optionally multi methods are the fastest solution, even though open pattern matching gives you other things like destructuring. Okay.
So you talked mostly about open methods and briefly mentioned multi-methods. If you had a magic wand and could add multi-methods to C++ in any way you wanted to and have the committee do what you wanted, how would you go about doing it, or would you go about doing it, or would you just make it a library feature like you've done here?
So if I could make the committee accept open multi-methods in one form or the other? Would I put them in a library or in a language? That's the question.
And what would they look like?
And what would they look like? Björn Stroustrup and his students created an implementation of open multi-methods as a compiler and linker extension. If you want to know more, come to the Inside yomm2 talk. And one of the points was to prove that you cannot implement open multi-methods as efficiently in a library. And of course, it is true. So if you want to know what they would look like, look up the papers. They're very easy to find, and they are very interesting papers. What I wrote is mostly a library emulation of what I believe should be a language feature.
So I noticed you have to register all of the derived classes, or some derived classes at least, when you're using this library.
Yes.
You don't have to register all of them, right?
So the question is, I have to register the classes involved in Open Method Dispatch, but I don't have to register all of them. You could get away with not registering all of them, but what matters are the classes which are actually specialized upon, right? In our example, it's node, number, times. But I would register all of them because, you know, the idea behind this is to be open, right? The idea is, especially if you're writing a library, you give the library and that implements matrices, and I am going to decide how to render them, how to export them to JSON or persist them or whatnot, okay? So if you just cover the subset of the classes that interest you, your library may not be as useful to me.
I guess I'm not thinking in terms of a library. It's more like if you have a base class that's very commonly used that has, and you want to add some sort of optional features that might have a sensible default implementation. It would make sense to only specialize derived classes that actually use a non-default implementation. And I was wondering, does your library allow that?
Yes. So the classes that you don't register will be completely transparent. It reminds me that, in fact, you know, those general features, because C++ gives us only virtual member functions, when you write a library, you have a tendency to put all sorts of things in the base classes. And that is the harm that OOP, traditional OOP based on member virtual functions, has done. It has given us visitor. It has given us God classes. And this is a solution to do away with them. Okay, we have 2 minutes.
Maybe you said it and I missed it. Were you able to access private data members in the open method or not?
Okay, so is there a way of accessing private data members from an open method?
Yes.
Currently, no. In a previous version of the library, yomm11, there is a feature that allows it. And if it's needed in yomm2, I know how to implement it. So yeah, when you need it, ask me. But you know, it sort of defeats the purpose, because the idea is that you can add functionality without touching the hierarchy. So if you, at one point, I will probably add the possibility to declare that an open method specialization is a friend of a class. But when that appears, please don't use it. It's defeating the purpose, right? The purpose is to have classes and class hierarchies that do one job well. For example, the AST library does node and tree correctly. It has a complete public API that allows you to manipulate trees. And then the consumers of your library, they will implement functionality, behavior using the public interface. That's really the good way to go.
Thank you.
So I imagine if this became a language feature, the syntax would be more convenient, or using it would be more ergonomic. Would you expect there to be a difference in the runtime performance between the library and the language implementation?
So if open methods were embraced by the language, would the syntax be different? Would it be nicer? Of course it would be nicer.
No, I'm actually more interested in the performance. Like I get that if it's a language feature, you can make it use syntax triggers also.
Uh,
Would you expect the compiler to be able to generate better code?
Okay, so I think that the syntax is actually quite bearable. Now, concerning the performance, come to the talk tomorrow. I'll go into details, but depending on what you accept to do, you see the problem with open method is that we know the complete set of methods that target a type much later than with virtual member functions. At the earliest, it's at link time, but then you have to take dynamic loading into account, right? So I think that unless you resort on dynamically modifying code, open methods cannot be as fast, but they can be very, very, very close. The only thing that differs, for a one virtual argument open method is that the position of the function will be floating inside the method table instead of being at a fixed index. Come tomorrow. Okay. One last question. We have 23 seconds. It has stopped. We have forever. Okay, go ahead.
So if I forget to register one of my derived classes or something like that, and I try to define a method on it, do I get a compiler error, or does it just fail silently and not call that?
So what will happen is that at one point, the library navigates from the object, and more precisely, the object's type ID, to a method pointer. So it won't be able to do that, and in a debug version, it will assert.
Oh, okay. Thank you.
But we need them in a language, okay? Thank you.